Hi. I was told that if I got an adorable child or a cute house pet, it would spruce up these videos a little. So this is Petey, and he's moderately cute, and so here he is. He's our new mascot. I attempted to bring an adorable child in here, which was the other suggestion, and I located one. But when I attempted to remove it from the front yard, the parents came out. There was a big hubbub. I got tased. So we'll have to settle for Petey here. What we're going to do is set up one of these lovely daylighting test sets in a number of ways and hopefully help to point out the methodology behind the operation of a closed loop sensor, which is different than an open loop control. And we'll take a look at that, and I will plot the results in Excel, and we'll look at that on a computer so we get a better look at it. Okay, Petey. There you go, buddy.
In brief, we're using a 0 to 10 volt CFL ballast. Of course, the control voltage is developed across these wires using a current generator internal to the ballast. Open for full output, shorted, of course, to bring the ballast output down to minimum. We're going to be attached to a control device, which is a closed loop sensor, photo sensor. It will not be operating like an open loop sensor, which uses a straight ratio of the amount of sunlight that the sensor sees divided by the sensor ratio, so that the controller is under the belief it has so much daylight here. Rather, we close the loop by allowing the sensor to see its own lighting. And what happens if we were to cover that lighting? Then all it could see would be sunlight, and what would that effect be? Here, in fact, is our entire daylighting system outside of the box. We're going to be measuring illuminance, which would be the combined illuminance. It's what a light meter always reads. And we will be measuring the control voltage developed by the control device. This is part of an automatic daylighting system course, and it's something everyone should know. Exactly what is the response of a closed loop sensor? What is the nature of its response? Well, here's one set up in a closed room. We can use the fact that it has feedback, and we'll seek a set point here to set it up for a specific illuminance level at a task surface. This is called, and if it's lower than the full output from the luminaire, this is called tuning. And it's automatically going to correct for age of the luminaire. So that is automatic lumen maintenance. If we cover the sensor, presumably the sensor will attempt to drive to its higher set point because it sees nothing now, and presumably will drive the luminaire all the way up. And if we let daylight in, it's going to see that combined illumination and adjust its electric lighting to hit that set point, driving it either up or down as required. But if we cover this lamp, it will only be seeing this other lighting in the area, be it daylight or intruding lighting from other general lighting. So it's going to seek to hold us at a design foot candle level, reducing the electric light as daylight comes in, or other light, because we haven't gotten to that yet. And we will be setting it for a specific set point to hold in the room. Now, if it can't see its own lighting, and some of you who are watching this are going to suddenly go, "Oh, I've seen that. I've seen that happening. I didn't know what was going on." I'm just going to cut to the chase. If the closed loop sensor is not situated so that it can see a sufficient amount of illumination from its own controlled lighting, then it's not going to move the lights when daylight comes in. What's going to happen is the daylight will come in and come in and come in, raising the combined illumination in the area because the lights are at full output or some high level, their highest level. And then when the daylight hits the set point, all of a sudden, this is going to take a tumble. Your electric lighting is going to go down. We'll discuss this again briefly right at the end of this thing. So let's take a look at what happens. Basically, we're simulating covering the controlled lighting in a closed loop daylit area. How will the controller respond? What will it do to the level out of the luminaires, presumably behind some piece of paper or something that we've taped over the luminaires? And we'll be able to see what the response of a closed loop sensor is, and they should all work this way.
Hello again. Let's refresh our memory on how a closed loop daylighting sensor works. I'm going to set this for 20-foot candles, no daylight, and partial as its set point, or somewhere around the middle of the response of the controller and of the system. And then we're going to cover the CFL with these scientific toilet paper rolls, and we'll use the daylighting source to vary above and below the set point, and we'll see how the controller reacts. Remember, this is the control output from the controller. This is your set point, okay? Above and below the set point, there will be a small region where nothing should happen. That's the dead band. When this drops to outside the dead band, the control voltage drops rises above the dead band, this controller will react and drop it somewhere within the dead band. So that's what's going to go on here. But you see, if it can never reach its set point, it's just going to keep going and going and going. So let's check that out. Okay, prior to calibration, I'm seeing a full output system under no daylight conditions of about 42 foot candles. We're going to do nighttime cal, and I'm going to bring it down to about 20 foot candles from the controlled lighting in the area, and down we go, and here we are, and that's about 20.8 it says, 20.9, close enough for government work. I'm going to end my nighttime cal, and I have to hold the button down for this, and the sensor indicates that I have stored my nighttime set point, and this will hold rigid now because, well, this will hold rigid now because we're in cal mode. So I'm just going to add about 15 foot candles to bring us up to about a 36 combined. Alright, and so what I've done is added about 15 foot candles to the mix, and now I'm going to put it in daytime cal mode, and I'm going to put the daytime set point down at 20 foot candles. Now remember, the feedback to the controller is the combined illumination, okay, and if it can't hit its set point, it's going to drive and drive and try and get there. So there's 20. So I'm going to hit store the daytime set point. It is storing the daytime set point. I am going to put it back into automatic operation, and when I shut the daylight, if you will, off, I've got 5 foot candles, and we can expect it to rise back up to 20. Back with you in a second. Right under no daylight conditions, it's gone back to about 21, which is where we set it. So we're ready to proceed with our experiment, and I'm going to put toilet paper rolls over the CFL, and we'll see what the control voltage does and all that. Now, we had been sitting at a control voltage of about 6.3, and it is coming up rapidly, 7.6. Let's examine this. Okay, we're at about 13 foot candles of added light coming in. and that is comfortably below our set point of 20. So this isn't going to move, it's going to stay maxed out. Let's put in more. Let's put in about 27. We begin to see the control voltage react. It's reducing. It has a long way to go because it has to get into the operating range, which is about 7.8. So let's give it a second. Okay, we're down to where dimming action is beginning to occur, a control voltage in the low 7 volt range. Our set point is going to remain, our illumination in the space is going to remain above the set point because we dialed it in. The controller cannot see its own lights, and its own light is not coming into this area. So we can expect that as we are consistently above the set point, the controller is going to drive this voltage all the way down to minimum, trying to find its set point. We have a situation where the controller cannot see its own controlled lights, and we are putting in 26-foot candles of daylight above the set point, and it is driving the system all the way down because it can never get down to its set point of about 21. We'll take it to around the set point so that you can see this action on the control voltage. It should be pretty immediate and interesting looking, and in fact would increase all the way up till it bumps into the top of the 10 volt range, because this is a closed loop sensor and it is searching for this set point, and it can't get the combined set point because it doesn't see its own lighting. Okay, I'm going to let this rise up to about 6.3 volts. See, we're under set point with our lighting, and that would be legitimately about where it was sitting to get 21 under no daylight conditions. So we're close enough. We're getting up to 6 volts there. What I'm going to do is raise the light in here above the set point, and we should see this thing make a U-turn and start heading back down to smack into the bottom of its range. So there's 6.5. Let's go up to like 24 or 25 foot candles to be on the safe side. And 6.91, 6.99, 6.95, 6.91. See, it took a U-turn. It's starting to head for the basement because now we're above the set point. This will continue to go all the way down to 0.08 volts. So you get the idea with this controller. It's got a set point with a little bit of deadband on each side. The system drives to find that set point. If it can't get there for some reason, like it can't see its own lighting, it drives all the way down to the bottom or all the way up to the top, depending on conditions. Alright, I've taken the toilet paper tubes off, and it can see its own controlled lighting. We've got about 12 foot candles of daylight in here. This should correct down to 21 now to show us that our controller is working properly, and now that it can see its own controlled lighting, it has that feedback and will be able to get us back into the range set by the deadband. It'll drop within the deadband around the set point, and we're at 21.7, 21.5. Our control voltage is fluctuating around 4.4. This should work just fine now, and that shows that a closed loop controller unable to find its set point, unable to reach its set point, will drive all the way one way or all the way the other. So that's very different from the open loop controller, which is just based on a ratio of presumed indoor light measured by looking at outdoor light, or estimated by looking at outdoor light. So it's a completely different kind of system.
So some of you may be going, holy compliance cow. I've seen this happening before. I hardly even leave the house, and I've seen this kind of thing happening. The example is a large open area. It was skylit with skylights, which were mandatory. It had troughers that were suspended down 10 to 15 feet from the actual ceiling, and the closed loop sensor was mounted about 6 inches away from the skylight up at the skylight. So there was no way it could see its own controlled lighting. As you might suspect, this thing took a tumble as soon as it got at reference. It could barely see any contribution of its own controlled lighting because the closed loop photosensor was way up above the actual plane of the luminaires and needed to be, one, moved further away from the skylight as the manufacturer required, and two, the closed loop photosensor needed to be suspended down to where it was almost at the plane of the bottom of the luminaires, because being unable to see its own controlled lighting, the lighting in the space, the combined lighting, simply increased and increased and increased until it suddenly dimmed down to full dimming. Now, in our little example, we simply covered the controlled lighting, okay, and use the daylight control to bring us above and below set point. The same thing would have happened if I had heavily masked the CFL with some kind of opaque material. The point is that the controller has to be able to see a significant contribution from its own controlled lighting. I'm not sure, but I'd say in a perfect world you would want 30-foot candles of daylight on the task surface and 30-foot candles of electric on the task surface to both appear to be of similar level to the controller, like that. You have to properly position a closed loop controller, or that control voltage is just going to run away up or down and fully dim or fully brighten the controlled lighting.